Find the equation describing the circle of radius r centered at 0, 0. So this is again something that's very good to understand properly rather than memorize. So what are we trying to do? We're trying to work out all the points, let's say x, y. So what's the crucial thing about a circle? A circle is all the points, so let me move this down a little bit. A circle is all points which are exactly the same distance from the center. So we're making the center the origin, 0, 0. So what we're trying to do basically is come up with all positions such that this length here is equal to r. That's what we want to do. So what condition do I need? Well, at least if I'm in the first quadrant, you can spot this exactly the same way as we did a moment ago. If I have a right angle here, then I can label the edges, so this would be x and this would be y. So by Pythagoras, we would end up with x squared plus y squared is equal to r squared now, not 1 squared. So in the example in the core video, r is equal to 1. It's exactly the same principle. And this actually works the whole thing. So if I was to draw a circle, an attempt at a circle, if I was to draw a circle of radius, so can I get this to work? If I was to draw a circle of radius exactly r, nothing's ever easy, is it? Where are we? Yeah, that's not bad. So if I was to draw a circle of exactly radius r, the positions on the circle centered at 0, 0 are all points x, y which are distance r out. So this is what we're looking for by Pythagoras' theorem. And as I said, that works all the way around the circle. You don't need to be in the first quadrant, it'll always work. The basic reason being that the distances or the lengths are just the absolute values of these, and the square of an absolute value is just the square of the original number. So a very useful thing to know.